students, today I am going to explain accuracy and precision along with error analysis. First of all, you see the error analysis part is very important as far as entrance is concerned, both NEET as well as your JEE Mains. So you have to clear the concepts, and also you have to develop your numerical ability in order to solve the numericals which come from the error analysis part. Okay, so let me explain about accuracy and precision. First of all, accuracy means what? Accuracy means what? It is the closeness of the measured value to the true value of a physical quantity. But I will explain by taking an example. So accuracy means for the closeness of the measured value to the true value of a physical quantity, means how the measured value is close to the actual value, true value, that gives you the accuracy. And precision means what? Precision means, first of all, it tells us up to what resolution or limit the quantity is measured. Okay, so it tells up to what resolution or limit the quantity is measured. Basically, it gives the idea about least count. So let me take one example, then to be more clear. For example, the true value of certain length, say 3.678 centimeter. This is true value. And while measuring, the measured values are suppose 3.5 centimeter, 3.3 centimeter, say 3.32 centimeter, say 3.256 centimeter. Okay, so suppose the true value of certain length is 3.678 centimeter, and while measuring with certain device, suppose there are four values, measured values, 3.5, 3.3, 3.32, 3.256 centimeter. Now out of this value, let us see which one is more accurate. So in order to find the accuracy, what we have to do? We have to just see which measured value is more close to the true value. Now if you see all these four measurement, this value is more close to the true one. So here what is the accuracy? What is the accurate one? The accurate value is 3.5 centimeter. But if you want to precise, which will be more precise? So what we have to see here? We have to see up to what resolution measurement is done. That means which measured value has more number of decimal points or more number of digits after the decimal points. That means which measurement gives you the least more number of digits after decimal points. So you see this one 3 digits after decimal points. So this device has least count 0.001 centimeter. and this one is least count 0.01 centimeter, and this one is least count 0.1 centimeter, and this also 0.1 centimeter. That means this gives the 3.256 centimeter means what? Here up to 3 decimal points measurement can be done. Here up to 2 decimal point measurement can be done. Here only up to 1, here also up to 1. So here up to 3 decimal point measurement can be done. That means it will be more precise. Okay. So this is the more precise value will be what? 3.256 centimeter. So here you can say this is more accurate but less precise. Similarly, this is more precise but less accurate. So you can say that accurate may not be precise or precise may not be accurate. So in order to find out accuracy, you have to only compare the measured values with the true values. The measured value becomes accurate if it is more close to the true value. But to find out the precise, you have to see up to what resolution measurement can be done. That means lesser the value of least count, more will be the precise. More the number of digits after decimal points means less is the least count, so more will be the precise. So this is all about accuracy and precision. Okay, now let me explain error. Now error means what? Suppose while taking the measurement of certain length, certain mass or certain time or any other physical quantity, we always may encounter some error. That means our measured value may be different from the true value. It may be greater than the true value or it may be less than the true value. So this uncertainty in the measurement is called error, which is the difference between measured value and true value. So error basically the difference between the measured value and the true value. That is called what? Error. Now there are mainly 3 types of error. Errors. The first one is systematic error. Systematic error. Now systematic error means what? It is those errors which occur in a certain pattern. That means it may occur in a particular direction, either positive or negative. Those errors are called what? Systematic errors. So you can say the errors which occur according to a definite pattern that is, or in one direction, you can say one direction means either positive or negative. So the errors which occur according to a definite pattern or in one direction, either positive or negative, then these errors are called what? Systematic error. So let me take one example. Suppose true value of certain physical quantity, say 2.5 centimeter. While measuring, your measured values are say 2.6 centimeter, 2.7 centimeter, 2.9 centimeter, 2.8 centimeter, So here you see, if we find the errors, then what will be the errors? Errors we know it is difference between what? Measured value and true value. So what is the difference between these two? It is 0.1 centimeter. Difference between these two, it is 0.2 centimeter. Difference between these two, 0.4 centimeter, and here it is 0.3 centimeter. That means you see all the values are what? Positive. But here if we take one value, suppose 2.3 centimeter, in that case the difference between these two will be what? Difference between these two will be what? Minus 0.2 centimeter. In that case it will not be a systematic error. So in systematic errors, either the error is positive or it is negative, but it cannot be combination of both positive and negative. So here the measured values in systematic errors, the measured values may be greater than or must be greater than the true value or less than the true value. Means all the measured values, in fact all the measured values must be greater than true value, so that errors are positive, or all the measured values will be less than the true value, so that errors will be negative. Means either the errors are positive or negative, but cannot be combination of positive and negative. So this is called what? Systematic errors. So they occurs in a fixed manner, means all the values are what? Greater than the true value, or it may be less than the true value, but will not be combination of both, that is positive as well as negative. So this is systematic error. Now these systematic errors are of three types. It is of three types. The first one is instrumental error. Instrumental error. Second one is imperfection. Imperfection in experimental technique or procedure. And third one is personal error. Okay, so systematic errors can be divided into three groups. One is instrumental error, then imperfection in experimental technique or procedure, and third one is your personal error. Now what is the instrumental error? Instrumental error means what? That is, the errors occurs due to the faulty instrument. That means you are using an instrument which is faulty, which is so faulty means what? Suppose just take one example. Suppose we are using a scale to measure certain length, but the scale, one part, say one end of the scale is broken. So this is suppose the scale, generally its mark start from 0 to suppose it is up to say 10 centimeter, 5 centimeter line. Now suppose somehow this part is broken. So here the scale is not accurate one. The scale is faulty because here 0 mark is not there. 0 mark is not there because it has already broken. So if we measure with this scale, then definitely you may get error, because here the scale itself is not 10 centimeter. It is less than the 10 centimeter because a part of it has already broken out. So if we use this scale to measure, then how will we get the accurate one? The result will be always less than what? The actual value. So here also you will get same type of error, that is value will be less than the true value. So if we measure this instrument, the error always comes and which will be less than the true value. So this is called what? Instrumental error. That is, the error occurs due to using of faulty instrument. Second one is imperfection in experimental technique or procedure. So if your procedure is wrong, or if you are using a wrong method, wrong procedure to measure a physical quantity, then also you may get same type of errors. Similar type of errors means either positive or negative. So here also you can take the example of scales. So in scale generally, so this is 0 and this suppose 10 centimeter, this is 5 centimeter. Now what is the procedure, what is the method to measure certain length with a scale? The procedure is that you have to start from 0. So 0 is the ending, 0 is the starting point. But suppose somehow you do not know the procedure or you are not following the procedure. Suppose you are using the starting point as 1 centimeter. So you are using, this is the starting point. But what is the correct method? Starting point is 0. But you are using starting point is 1. That means you are taking a wrong procedure. So in that case, if you measure certain length with the scale and you start from 1, then definitely you will get an error. And your measured value will be always less than the true value, because you are using a wrong method. Because correct method is what? You should start from 0, but here you are starting from 1. So definitely you will get an error. So this error is not because of your instrument. Your instrument is correct, but because of your wrong procedure. Procedure is what? You have to start from 0, but you are starting from 1. So this is the error because of imperfection in the experimental technique or procedure. And last one is personal error. Now this personal error, it is because of what? It is simply personal bias, you can say, that depends on the individuals. So why this personal errors occurs? It occurs because of carelessness of the person, because of lacking of proper setting of the apparatus. So whenever we do some experiments, we should have a certain arrangements. So if we do not properly arrange the apparatus, then there may be chances of getting the errors. Or if we do not follow the right methods, right procedures, then also we may get the errors. If we do not, if we become carelessness while taking the measurement, then also we may get errors. So there may be some personal defect also, there may be eye problem, there may be hearing problem, then also you may get error. So it comes due to improper technique of the person, improper arrangement by the person, then some defects encountered by the persons, or carelessness of the persons. So this is called what? Personal errors. Now, so these are the systematic errors. Now the point is how to minimize systematic errors. First of all, we cannot make it 0, but we can minimize it. So in order to minimize it, the thing is that first of all you should use right instrument. Number 1, the instrument should be correct one. Then second, we should use the right techniques, right method, correct method. And third one, we should reduce or minimize the personal bias. So if we follow these techniques, then we can minimize systematic error. Okay, so this is all about systematic error. And second one is called random error. Random error. Now the random, that is the name suggests irregularity. So random means what? The errors may occur in an irregular manner. That means there will be no pattern. That means errors may be positive or may be negative. It may occur, it may not be occur. So this is also called a chance error, because there may be a chance of getting error or there may not be error. So we do not know actually whether you will get error or not, or in one direction. It may be positive, it may be negative. So there will be no informations about the errors. So that's why it is called what? Random errors. Now the question, how this random error occurs, or when it will occur, or why it occurs. First of all, it occurs due to some fluctuations in the environmental conditions, or which cannot be controlled by us. So that means these fluctuations may occur and which cannot be controlled by oneself. Then you may get random errors. You can take one example. Suppose while measuring pressure of a certain, suppose you are measuring the air pressure of this room. So what we use? We use Boyle's law. And what is Boyle's law? You know, pressure proportional to volume, inversely proportional to volume. But here certain condition is there, that is temperature must remain constant. If the temperature remain constant, then only you can use Boyle's law. But suppose in your experiment the temperature is changing, and it's changing randomly. Randomly means what? Sometimes temperature increases or sometimes it decreases, and which cannot be controlled by you. So in that case, the measured values may differ. You may get values, suppose high values. After some time you are getting low values. Means several different types of values you may get, because temperature does not remain constant and is fluctuating. And fluctuating like that, sometimes it goes higher, then it comes lower, again higher, again lower, but how it changes you do not know. And in that case you may encounter this random error. Or another example you can take, say you are measuring current. Current given by potential difference by resistance. Suppose you are measuring current in electric circuits, and by somehow the potential fluctuates. It is fluctuates, suppose generally the potential is 220 volt, and suppose it fluctuates between say 100 to say 150 volt, and the fluctuations is not irregular manner. That means what? Suppose it becomes 150, then again 130, then 120, 110. That means you do not know whether the voltage increase or voltage decrease. There will be no informations. You cannot guess कि voltage now increase or voltage now decrease. So there will be no idea, no informations. So in that case, your measured value, the current, sometimes you will get more, sometimes you will get less, or sometimes it may be accurate one. So you cannot predict what type of error you may encounter. So that type of error is called what? Random error. So random error means what? The errors of irregular pattern, or errors which may occur or which may not be occur, and it may be positive, it may be negative. So that type of error is called what? Random error. Means we do not have any information about the error. We cannot predict what type of error we may encounter. So that's why it is called random, or also called chance error, because there may be a chance of getting error or may not be a chance. So this is called random error. Then the third one is least count error. Least count error. First of all, least count means what? Least count is what? It is the smallest value up to which measurement can be done with an instrument. That smallest value is called what? Least count, because the name suggests least, the smallest. Say for example, the scale which we are using, we are using to measure certain length. What is the minimum value of the scale? 1 1 millimeter, that is 0.1 centimeter. That means with that meter scale we can measure up to 1 millimeter or 0.1 centimeter. We cannot measure length which is less than 1 millimeter, because the least count of the scale is 1 millimeter. So we can measure up to 1 millimeter. So this is the least count. We have certain other devices by which you can measure distances, lengths which is less than 1 millimeter. Say for example, we have vernier calipers. We have vernier calipers. So you will get in practicals. The vernier calipers, its least count is 0.01 centimeter. We have screw gauge. And its least count is what? 0.001 centimeter. So with vernier calipers you can measure up to 0.01 centimeter, and with screw gauge you can measure up to 0.001 centimeter. So now what is least count error? Say for example, the true value of a certain length, say 3.32 centimeter, but you are measuring with a scale which least count is what? Least count is 0.1 centimeter. So your measured values will be say 3.3 centimeter, 3.2 centimeter, 3.1 centimeter, because you are using the scale which least count is 0.1. So you cannot measure value which is less than 0.1. So here you will get only up to 1 decimal point. You cannot have 2 decimal point, because your device, your scale has minimum value 0.1. So you will get only 1 decimal point here. That means you are getting error, because here 3.32, this value you will not get here. So that means you will encounter error, and this error you are getting only because of the least count, because this least count, it has least count 0.01, but you are using the scale which least count is what? 0.1, which are not what? Matching, which are not equal. So you will definitely get an error, which is called what? Least count error. Okay, so this is all about error, some basic definitions and concepts. Now here I will explain some other errors which are very important for your entrance exams. That is the absolute error, relative error, and percentage error. Okay, so first let me explain absolute error. So absolute error means what? It is the difference between the measured value and the true value. That is simply called the absolute error. So you can say that magnitude of the difference between measured value and true value of a physical quantity. So the absolute error is what? It is the magnitude of the difference between measured value and the true value of physical quantity. That is called what? Absolute error, and it is denoted by delta A. So therefore delta A, it will be the magnitude. So you take the magnitude, the difference between measured value minus true value. So this is called what? Absolute error. Now come to absolute error. So mean absolute error means what? If we take the mean of all the absolute errors, that is called what? Mean absolute error. So all the absolute error means what? Suppose there are 4 measured values, so there will be 4 absolute errors. Then you take the arithmetic mean of the 4 absolute errors. That gives you what? Mean absolute error. So this is simply mean value, the arithmetic mean, of all the absolute errors. Of all the absolute errors. It's called mean absolute error. It is denoted by delta A mean. So obviously, what will be delta A mean? Delta A mean, you can write simply delta A1 say plus delta A2 say up to delta AN divided by n. So this is what absolute error of say A1, absolute error of say A2, absolute error of say AN divided by n. So this will give you what? Mean absolute error. Okay. So let me take one example, then it will be more clear. Let the values obtained in several measurements are say A1, A2, A3 up to n. Suppose we are taking n measurements of a certain physical quantity and we are getting these values A1, A2, A3, An. Now here I have to find the absolute error and mean absolute error. So what do we get? What do we do? First of all, here you see true value is not given. So if true value is not given, then what do we do? We have to take the average of this. That gives you the true value. This you have to remember. If in certain cases the true value is not given, then in order to find true value, we take the average of all the measured value. That will be the true value. So here your true value will be A1 plus A2 plus A3 An divided by n. So this is, you can say, A mean. This true value. You can write it like that, summation I is equal to 1 to n Ai divided by n. So this is the true value. That is the mean value of all the measured value gives you the true value. So this you have to remember. So now we get the true value. So first you find the absolute error. Therefore indivisible absolute errors. That is delta A1. So it will be, you know what is the absolute error? Difference between measured value and true value. So measured value A1, true value is what? Mean, A mean. Delta A2, it will be what? A2 minus A mean. Similarly delta An, it will be An minus A mean. So therefore, what is the mean absolute error? Mean absolute error. What is mean absolute error? It is the mean of all the absolute errors. So you take the magnitudes of all the absolute errors. Delta A1 plus delta A2 up to delta An divided by n. So this is the mean absolute error. So this you can write So this we can write delta A mean, it is the mean absolute error, is equal to, you take the summation I is equal to 1 to n, that is delta AI divided by n. So this is mean absolute error. Okay, so this way we can calculate mean absolute error. So first of all, what are the steps? Suppose some measured values are given. First you have to find out the true value. So what do you do? You take the average of all the measured values, that gives the true value. Then you find the individual absolute error. So what do you do? Subtract the measured value and the true value, that gives you the individual absolute error. Then you find out the mean absolute errors. What do you do? You take the average of all the individual absolute errors, that gives you the mean absolute error. So this is all about absolute errors. Now come to relative error. Relative error. The relative error means what? It is simply mean absolute error divided by mean value or true value. So simply you can say that the ratio of mean absolute error to the mean value or true value is called what? Relative error. So this is simply mathematical definition. You just remember this relation. So this you can write delta A mean divided by A mean. So this is what? Relative error. And then percentage error. Percentage error. So percentage error means what? If we convert relative error into percentage, that is called percentage error. It is relative error into 100%. So this is called what? Percentage error. Or simply you can write delta A mean divided by A mean into 100%. So this is called what? Percentage error. Okay. So let me repeat. Here we have absolute errors, relative errors and percentage error. So absolute error means what? Simply the magnitude of the difference between measured value and the true value. Then mean absolute error means what? The arithmetic mean of all the individual errors. Then relative error means what? Absolute error, ratio of the absolute error, mean absolute error to the mean value or true value. And percentage error means what? If we convert the relative error into percentage, that is called what? Percentage error. Okay. Okay, so let me take one example, then it will be more clear. So in successive measurements, the readings turn out to be 2.63 second, 2.56 second, 2.42 second, 2.71 second, 2.80 second. Now calculate absolute error, relative error and percentage error. Just I am taking one example. Say in the measurement of time, suppose, because unit is given second. In the measurement of time, we are getting this 5 values: 2.63, 2.56, 2.42, 2.71 and 2.80. Now from these values you have to find out absolute error, relative error and percentage error. Now what we do? First you have to find the true value. So true value means what? The mean value of this. That is A mean. So A mean means what? You take the average. That is 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 divided by 5. So it will be 13.12 divided by 5. So if you divide, it comes to be 2.624 seconds. Now here you have to round off. I have already given you the rules of significant figures. Here all these measured values have two significant figures after the decimal point. So in the result also it should contain two significant figures. It will be 2.62 seconds. It is after rounding off up to 2 decimal point. Okay. So this is our true value or the mean value. Now you can find the individual absolute errors. That is individual absolute error, that is delta A1. It will be A1 minus A mean. So 2.63 minus 2.62. So it is 0.01. Then delta A2, it will be A2 minus A mean. It is 2.56 minus 2.62. So it will be minus 0.06. Then delta A3, it will be A3 minus A mean. So 2.42 minus 2.62. It will be minus 0.2. Then delta A4, it is A4 minus A mean. So it is 2.71 minus 2.62. So it will be 0.09. And lastly delta A5, it is A5 minus A mean. It is 2.80 minus 2.62. So it will be 0.18. So here I am getting the individual absolute errors. Now you find the mean absolute errors. So your mean absolute error. Mean absolute error. It will be delta A mean. So it will be delta A1 plus delta A2 plus delta A3 plus delta A4 plus delta A5 divided by 5. So here you have to put the values. So here you see this, it means what? It means modulus, magnitude. Okay, magnitude means what? If delta A, for example, you see this is 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 divided by 5. So it will be delta A mean, it will be 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 divided by 5. So this modulus means what? The negative of a modulus is always positive. So it will be 0.54 divided by 5 or 0.1 or 0.11 second. So this is your mean absolute error, delta M. So this is mean absolute errors. Now you have to find out relative error. This is mean absolute error. Now relative error. So what is the form of relative error? It is the mean absolute error divided by mean value. So here mean absolute error is how much? 0.11, and what mean value? mean value was it will be 2.62. So here you have to divide. So if we divide 0.1 by 0. This 1 by 62, it comes to be around 0.04. Okay, you just divide, it will be 0.04 around. Therefore, percentage error. Percentage error means what? Relative error into 100%. Now here relative error is how much? 0.04 into 100%. So it will be 4%. So like this, we can calculate your relative error, absolute error, and percentage error.